Hello everyone, my name is Meethun Panda, and today I'll be presenting an interesting topic, which is how should we think of scaling AI with large language models. As you see, since the advent of ChatGPT in November 2022, there has been a lot of disruption that is happening in the field of generative AI, and we see every week we see a new sophisticated models. Now, key for us and key for some executives, key for the executives is how can they leverage large language model, what the ecosystem should look like, what the architect should look like, and what the infrastructure should be to make sure that now you'll be able to scale the generative AI use cases. So from my experience, I have brought few content, but important is what should be the key design principles, and to make it very simple. If we want to enable generative AI use cases at scale, of course, the infrastructure has to be in the cloud. That they must to adapt in any situation, solving so many use cases. We are not talking about just building one chatbot kind of use cases. It's throughout building a whole portfolio of generative AI use cases across the organizations. So first design principle is flexibility. So making sure that your design principle, architecture design must be flexible enough, because as I mentioned, we have new large language models coming up every week. So making sure that you are not locked. Your architecture must be flexible. Second is scalable. It's no deniable fact that your architecture must be solid to basically support the scalability of it. So cloud, definitely the cloud and elastic scaling and hosting, leveraging the cloud capabilities, and you can achieve that. And the third is the security piece of it. Security is very important, and as we know that the privacy and security and is very important when we try to scale on generative AI use cases. And the final is the monitoring. We always leverage some tools, but making sure that we have the right rigor on the monitoring of generative AI use cases. Now, when you look at the AI-driven ecosystems, on the architecting AI-driven ecosystems, infrastructure is really important. And this is where we have the compute, you have the storage, you have the network, the monitoring, provisioning, etc. And for the generative AI applications, we have GPU is really important to drive and to train the large language models and to drive that kind of applications, right? The next is the data management engineering, which we have been doing this since the traditional machine learning and AI side of it, where we need to integrate with various source systems, acquire the data, ingest, store, and making sure that we have the right data governance piece of it. Then we go to the analytics platform side of it, which is number third bucket, as you see, third layer, and which is where we build the models, we serve the model, we train the model, we test the model, etc. And then we go to the modern software platform. So what modern software platforms talks about is our architecture designed for real time or event driven or microservices, and making sure that how AI can be embedded into various business processes. We are working in fintech, we are working in healthcare, we are working in pharmaceutical, irrespective, making sure that AI is embedded into various business processes to drive value. And the finally, number 5 point is the digital channels and the experience of the modalities. And this is where you have mobile, you have wave, we have wearable devices. If you are working in the healthcare industry, you have wearable device and the data you are getting with you are going to connect with the various source systems, integrate with your platform. And the seventh is the security. Security is really important. And as you see here, seventh is vertically cuts across in all the channels here. So making sure that you have the right privacy and security first architecture. It's a kind of shift left approach. You should not think that at the end, it should happen from the beginning of your architecture landscape. Now, to deep dive here, this is what kind of, again, this is an illustrative, but if you see here, number one, infrastructure on the bottom side of it, bottom part of it, where we are leveraging cloud and distributed computing, moving away from on-prem to now cloud and then multi-cloud approach as well. This is where we leverage GPU as a service as well, the serverless storage, scalable storage, infrastructure provisioning, etc. Then we go to the data management engineering side of it. Now this is where we ingest the data, we capture the batch or the real time, change our CDC. We transform the data, we make sure that we apply the data quality rules. And then for the generative AI, I'll just focus on the generative AI component here. And vector database is very important here in second layer, which is the data management and engineering. And this is when we leverage the semantic power of vector database, right? And on the LLM side of it, we have open source LLM, we have closed LLMs, but making sure that based on your use case, you are leveraging the right large language model, and make sure that you're also evaluating, right? The selection of LLM is happening correctly. Then model serving, LLM inference is really important, and this is where it depends again on the use case, that how much latency that you need is really important. And finally, the final layer is the AI application and software, and then finally digital channels. It's been a view of how all the layers are stacked together, how your ecosystem should be together, and the options that you have. Now, what are the kind of strategic foundational choices we should be thinking on generative AI building blocks. Again, going back to the 6 layers that I defined earlier, was the infrastructure. So we have a lot of choices, right? We have single cloud, we have multi-cloud, we have SaaS, there are a lot of infrastructure, NVIDIA. This is infrastructure as a service is also going to be very important, and it's coming up as well. Second is the vector databases, and vector databases, and we have open source and we have paid, such as Pinecone or VB8. There are a lot of enterprise level vector storage or application level, and so on and so forth. So maybe a database approach. So please ensure that and make sure that your architecture is really flexible and solid. Then LLM selection. I again going back to my previous what I just mentioned, making sure that you are selecting the right large language model for your generative AI applications. And then the ML ops or LLM ops platforms, right? You can leverage definitely open source, or you can go and bring the best of breed kind of niche. There are a lot of plenties available in this market. And finally, multi-cloud architecture on generative AI, right? This is a no-brainer, and the adoption of multi-cloud that is happening these days and which will continue to happen. And I have solved various clients on their generative AI, building generative AI applications leveraging multi-cloud. So that's it. As that large language model, unstructured data is a fuel of large language model. But if you look at the traditional last 30, 40 years in the industry, we did not pay a lot of attention, or we did not apply the same rigor to unstructured data management than we provided to structured data management. And it's very obvious, right? It's very obvious. And I still believe that there are 3 key data management challenges here, right? One is units within the firm. The second is in the storage piece of it, right? And making sure that you have the right governance and the storage practices. It should not be sitting in your email, or it should not be sitting on your hard drive, right? It should be in a centralized and must be labeled correctly. And then extracting and transforming, basically ETL side of it, making sure that you have the right data pipelines with the right governance strategy. This way you'll be able to really leverage the power of the unstructured data to drive your generative AI use cases. Now, look, there are certain difficulties in building an operational generative use cases as well, right? The typical AI ML project challenges, we already know that. But in terms of technical challenges, definitely you see hallucinatory response, right? But again, there are certain techniques that we must adopt to reduce the hallucinations. Your ML ops, you have databases, video databases, you have cybersecurity risk, you have diverse data improves, and then you have scalability challenges and deployment challenges as well. And making sure that you have the right key ecosystems or right flexible architecture in terms of to deal with the technical challenges. In terms of the operational challenges, and we already know that, because UI, user interface, and user experience is very important. If we are building generative AI applications, it should have the right roadmap, and then also right talent strategy. And there's going to be another conversations if we look at applications. Now, again, going back to the tech stack and the architecture, it's very high level. Again, this is illustrative, but I'll really emphasize on 6 key elements as we think of. One is the generative AI tech stack, and then data and infrastructure side of it. As you see, the first 3 architecture elements, which is the large language models, and then embeddings, and the vector database. These are really important. And what should be your decisioning criteria to choose LLMs or the embeddings or the vector database? Now, to choose the large language model and embeddings, definitely its capabilities, right? It's not just one large language model is going to cover or solve all kinds of use cases for you. So making sure that you have to understand the capabilities. The second is the security aspect of it. The third is ease of use. And the fourth is also multilingual capabilities that also you need to think of. In terms of the vector database, again, we go with the latency, the performance, and scalability side of it, flexibility, and then availability. Not all the vector databases are available in every cloud, but making sure that you understand that what kind of vector database would be appropriate for your organizations. And also cost is very important. Then in terms of the infrastructure, again, it's very simple: platform, hosting, and data store. In terms of the platform, again, we already know that. What should be your decision for considerations? Again, it's a kind of a choice. We have compliance with the security team, the security norms of your organizations, and scalability to accommodate new use cases, making sure that your platform and the infrastructure is really robust to help you accelerate various use cases. Now, just a couple of examples in here. It's very intuitive to understand and how it fits together, those 6 elements. So we have a bunch of documents on structured data. Then we provide a chunking strategy. We just create chunks or divide into chunks, and then we embed and load into vector databases. This is very simple, right? And both metadata and document embeddings are prepared here, and then we gets loaded into vector databases there. And then in your architecture, basically, when a user query comes, then again, we send it to the LLM, and the LLM kind of refresh, making sure that gets again embedded using the same embedding technique which we passed to load into vector database. and then the similarity or the semantic search happens against the vector database, then you get retrieve top 3 or top 5 or top kind of retrieve documents, and then basically it gets fed into the LLM, and then you get the right answer, right? And this is just a very, very basic naive approach of a RAG, retrieve augment generate application. So there is more. Finally, I'll end up giving this last piece here, that if you want to scale your generative AI use cases, so your delivery team must have the right capabilities, starting from your use case definitions, making sure that you have you're defining the use case properly. You are identifying what the KPIs should look like. How would you measure the performance? How do you measure the KPIs? This is very important. What is the value you are going to get out of it? The second is the definitely discovery part of it. What kind of data is necessary to enable that particular use cases? And then third is the setup, right? Do you have the right infrastructure? Did you choose the right LLM? Did you choose the right vector database, etc., etc.? And then you start getting into the development piece of it, then making sure that you are designing the UI and UX and developing the UI perfectly, your backend is correct, making sure that it is modular and flexible architecture, leveraging containerization principles and the techniques. Then you move to the deployment and monitoring side of it, and then finally application maintenance and support. Now, in terms of the key resources, definitely we need data engineering team, data science, data engineers, data scientists, LLM ops or ML ops or data ops, whatever you call it, ML engineers, then product owner, product managers, site reliability engineers, UI UX developers. So it's across, starting from the use case definitions, from discovery to design to development to deployment to maintenance and support. That's all about this presentations, and I hope this is very short, and hope you like the conversation, you like the presentation. Thank you very much.